A monomial and a term in algebra represent the same thing, and they are any combination of variables and numbers multiplied together. So as long as it's multiplication between the variables and the numbers, what we get is called a monomial or a term. Now what we want to look at is some multiplication and division and a little addition and subtraction with these monomials. First of all, here I have 1, 2, 3 monomials multiplied together. I'm going to use my commutative and associative properties to rearrange the numbers and variables so that I have all the numbers together, these coefficients right here, all the x's, so I have x squared times x cubed times x, and then all the y's. I have y times y cubed times y to the fourth when I take these y's and rearrange them over here. As long as it's all multiplication, I'm free to do that whenever I want. 4 times 3 is 12, times 2 is 24. X to the 2 plus 3 is 5, plus, that's an exponent of 1, so I have 6 for that. And y to the 1 plus 3 is 4, plus another 4 is 8. Remember, I add exponents when I multiply with the same base. So a nice simplification down to 24x to the 6th, y to the 8th. Here's a division problem. 21a squared b cubed over negative 7a b to the 5th. Now we're going to sort of go backwards from multiplication with fractions to rewrite the problem this way. 21 over negative 7 times a squared over a times b cubed over b to the 5th. Now that's, if I was going to multiply these three fractions out, I'd multiply numerators, I'd get this. Multiply denominators, I would get this. So I'm just showing that we can divide it back up like this and group the numbers together, the a's and the b's, as long as this is all multiplication and division. Now I divide here, I get negative 3. A squared divided by a to the 1 is a to the 2 minus 1, which is a to the 1. And then this is b to the 3rd divided by b to the 5th, so it's b to the 3 minus 5, which is negative 2. Now, what we usually like to do is to write our variables with positive exponents only. So I'm going to write this over b to the positive second power instead of times b to the negative second power. So negative 3a over b squared is the simplified version of this division problem right here. Here's one that involves scientific notation. Same type of problem, except that I'm writing in terms of scientific notation, so I'm going to do the same thing and write this as 8.4 divided by 2 times 10 to the 5th over 10 to the 2nd. I can do that because if I multiply these two fractions, I get this fraction right here. But that allows me to divide the number, to separate the number parts from the powers of 10. 8.4 divided by 2 will be 4.2 times 10 to the 5 subtract 2 is 3. So there's my answer, and my answer turns out to be written in scientific notation. I have the 4.2 times 10 to the 3rd power. I could write that out the long way if I want, or more conveniently probably just leave it as scientific notation. Here I have 3 monomials or terms that are similar to each other because the variable parts are the same. Just want you to recall that we add these by using the distributive property, 10 minus 8 plus 2, all times x cubed. There's my application of the distributive property. 10 subtract 8 is 2, plus 2 is 4, x to the 3rd power. So I can add similar terms or similar monomials. Those will be monomials or terms that have the exact same variable part. So there's some multiplication and division and a little addition and subtraction with monomials.